So let's look at the other law. We are talking about in connection to radiation, right? Two laws that governs how much radiation a body emits or how much will it absorb. So related to that, you have this particular one more law. So Kirchhoff's law of thermal radiation. What does it talk about? It connects how well a body absorbs radiation and how well it emits radiation. Perfect. So that's what we're looking at. Basically, the law tells, okay, a body can emit only those wavelengths that it is capable of absorbing. And it can absorb only those wavelengths it is capable of emitting. Okay, so this is a bit out of syllabus. What I'm going to give the reason. At least in terms of physics, it's out of syllabus. It will come. You guys will be studying next to next semester. That is second half of your 11th and 12th grade as per the syllabus as of this academic year. How things are structured now. You'll be studying it next to next semester or in the future basically. See, and this is related to chemistry. You might study in chemistry. So you know that electrons, they exist in orbits, that is specific energy level. So when they jump in and out, right? When they jump in and out. So when they jump out, this happens with energy coming in, right? So this jumps out. If this is not a particular value, it won't be able to jump to that particular next level or a particular level. Any other value, plus or minus, it won't be able to jump. And when it comes out, comes in, it will emit this same thing again, same wavelength. Because this too has a specific energy level. So this is at, say, x joules. And say this is x plus 1. Again, I'm oversimplifying this. Please don't take this as an absolute idea. So if this is x joules, this is x plus 1 joules. So this has to be 1 joule, or let me take it as 4 so that it's easier. So this has to be 4 joule and this will be 4 joule. Okay, guys. So x plus 4, right? So this is how they behave. The atoms and the electrons and the outer shell and all of this. This concept is something that we'll be teaching, and I'm not very well versed with chemistry syllabus per se. So I can't definitely tell if you guys know this by now. I think you guys will be knowing. I mean, 9th and 10th and all, we have this. So, yeah. Okay. So, sorry. I kind of got distracted. So, why does this happen? Why is this person telling this, and why does this happen? A body can emit only those wavelengths that it is capable of absorbing. So what is this wavelength and stuff? So you guys know waves. Waves is one more chapter that we'll be studying, right? So waves is, example of a wave is this. You guys have studied sine wave and cos wave. So you should have studied. So wavelength is what? This is a wavelength. From here till here. This is to do with energy level. In atoms. Again, all these are rough idea. So this wavelength, this has a particular wavelength, this has a particular wavelength, and this two have the same wavelength actually, right? So these two have the same wavelength. So only with that wavelength, you will jump in and jump out. Okay. So if this is how the nature works, obviously this makes sense. Right? If that is very clear, this should make sense. Both emission and absorption depends on the same internal energy level. Transition of the material. So whenever a material can absorb, whatever a material can absorb well, it must also emit well. So the statement of this particular law is that for a body in thermal equilibrium is one more definition that we'll be learning. The emissivity for a given wavelength and temperature is numerically equal to the absorptivity for the same wavelength and temperature. So it's the fancy way of telling whatever we just learned. Yeah, that is the statement. I can't help that. I can't make that simple, guys. That you have to learn. But it means this. Okay. So you can have a look at this.